Hello, welcome to Zigmatech Learning Hub. I'll be your instructor for geography. For this class, we are going to be taking our exercises from the Exam Guide app. If you don't have the application already installed in your device, I will want you to download the app in order to follow along in this class. Exam Guide is a leading educational app that helps students prepare adequately for various exams like UTME, Post-UTME, WAEC, GCE, KCPE, IJMB, JUPEB, Carbopedia, BECE, JSE, NCE, NECO, etc. You can download the app from www.examguide.com or Google Play Store. Please subscribe to our channel and turn on the notification bell to be updated on new videos. Ready for today's class? Okay, let's get started. So in today's lesson, we are going to be looking at the Earth's structure. So let's quickly look at what we have in the menu for today. So today we are going to look at the major sphere of the Earth, and we are also going to look at the component layer of the Earth's crust. Then we'll look at the various characteristics of these layers that we have on the Earth's crust. And then we're also going to look at the cross-section of the Earth's interior, starting from the lithosphere down to the core. And then we're going to look at the relationship that we have between the atmosphere, biosphere, lithosphere, and hydrosphere. So before we actually commence, if you look at the physical nature or structure of the Earth, you will see that the Earth is actually composed of layers, internally and externally. And this discovery was first discovered by a scientist called Mohorovičić, in 1909, whilst he was studying about earthquake of the Earth's crust. So he discovered the different boundaries or layers of the Earth, and those layers are actually regarded as the seismic boundary. And this discovery, led to further and further discovery about how the Earth, resembles, or how the layer of the Earth is being composed. So let's look at these layers. So the Earth's layers is actually divided into two. That's the Earth structure. It's divided into the external and the internal. So the external starts from the Earth crust, which is the lithosphere, where we are, standing on or living on, down to the extreme end of the atmosphere. So the external structure is made up of the lithosphere. Then as you go up, we have the atmosphere. Then we have the hydrosphere and the biosphere. So these four components are the external structure of the Earth. So let's look at them one after the other. Now the first layer, which is the lithosphere, is the outer solid layer of the Earth. The land mass that we build on, that we live on, that we move on, is actually the lithosphere. So the lithosphere is formed by solid substances, and these substances are actually called rocks and minerals. And is the uppermost portion of the lithosphere we have is made up of things like clay, things like loamy soil, gravel, silt, and other minerals and rock we have on the Earth's surface. So that's what make up the lithosphere. Then if you look at the atmosphere, which is right above the lithosphere, is actually the layer of the external structure of the Earth that is made up of gases. The atmosphere is solely made up of a mixture of gases, and we have gases such as nitrogen, oxygen, carbon dioxide, and other noble gases, in the atmosphere. So this atmosphere, is what surrounds us, from the top. And we need to look at the composition of the atmosphere. So the atmosphere is majorly made up of nitrogen. Then we have oxygen, and we have other gases and carbon dioxide. Now nitrogen actually has the highest percentage, of the atmosphere. About approximately 78% of the atmosphere is actually made up of nitrogen, while 21% is oxygen, and about 0.5 0.04% is carbon dioxide, and the remainder, is what comprises the noble gases. Then we have dust and water vapor at variable amounts. So let's look at a table showing the composition in terms of volume. Now for nitrogen, we have it about 78.084 percent by volume in the atmosphere. Then if you look at the oxygen the second with about 20.946, or you can approximate it to 21%. So 21% of the atmosphere is oxygen that we actually use for respiration. Then we have noble gases like argon, about 0.934%. We have neon, about 0.00182%. Same as helium, which is about helium is about 0.00052. That is almost, let's say approximately the same with neon. And then we also have krypton, which is almost the least in terms of the noble gases we have in the atmosphere, which is about 0.00011% by volume. Then we have methane as an organic gas in the atmosphere. Methane is about 0.00015%. And these gases are in very minute amounts in the atmosphere. And when you sum them up in terms of volume, we're going to have a total of 100% of gas in the atmosphere. So that's the composition of gases we have in the atmosphere. So let's take a look at the atmosphere. Now the atmosphere is actually in different layers. Now we have about 4 layers of the atmosphere. The first one is called the troposphere, which is the lowest, the one closest to us, where we have rainfall and we have a bit of clouds formed there. Then if you go right above the troposphere to the stratosphere, if you go right above the troposphere, we have the stratosphere, and the stratosphere is the second layer, and it's just about 11 to 50 kilometers in terms of width, and the temperature drops as you move from the troposphere to the stratosphere. Then the next layer is called the ionosphere. Now the ionosphere is actually made up of 2 layers. It's made up of the mesosphere and the thermosphere. And in the ionosphere, we actually have ionization of gases, happening in that layer of the Earth. Then when you move right above the thermosphere, which is a bit hotter, you get to the exterior part of the Earth and you get to the atmosphere. And the temperature, falling down there is about minus 1,200 degrees Celsius. So as you move from the Earth, the lithosphere, you get first to the troposphere before going to the stratosphere. Then as you move from the stratosphere, you go to the ionosphere, which is made up of the thermosphere and the mesosphere. Then you finally get to the exosphere, which is the exterior part of the Earth. And from there you can now get into what? Into space. So let's look at them one after the other. Now let's look at the lowest, which is the troposphere. Now the troposphere is extends about 14 kilometers away from the Earth's surface. So as you move from the Earth's surface, you get to a height of about 14 kilometers and above. Then once you get to that height, where you have the clouds and where you have rain formation there, you've actually gotten to the troposphere. And in this troposphere, it's a very essential layer of the Earth, because some meteorological activity take place in the troposphere. And the meteorologists, they actually study this particular layer of the atmosphere because of climate purpose or weather reasons. And as you go to the troposphere, the temperature keeps dropping as you go up and up and up. And we call that lapse rate. So for every 0.1 degree, for every 100 meters of height you actually cover, the temperature will drop by 0.1 degree Celsius. So that's how it works. That's how it happens as you go up and you go up and you go up. In fact, as you get towards the exosphere, you discover that the temperature has dropped drastically compared to what it is on the Earth's surface. So we look at the second layer of the Earth, which is the stratosphere. Now, it's just right above the troposphere. And in the stratosphere, we have the ozone layer there. Now, ozone is actually O3, and the ozone is very much important when it comes to the screening of light rays, and when it comes to, preventing harmful radiation from reaching us on Earth. So the stratosphere contains the ozone, and the ozone helps to, filter the sun radiation, and, prevent us from having, or prevent us from suffering the effect of the harmful radiation of the sun. And if you get to the stratosphere, the air in the stratosphere is usually what? Very dry, So this is as a result of the heat we have there. When the heat is generated during ultraviolet ray absorption, you will discover that the atmosphere there is usually what? Drier. Then after the stratosphere, which is 48 kilometers from us, you get to the next layer of the Earth, which is called the ionosphere. Now, the ionosphere is between 48 kilometers to 483 kilometers above the Earth's surface. And in this layer, we have two sub-layers. Now, the first layer is the mesosphere, and the second layer is the thermosphere. Now, in the ionosphere, we actually have ionization of gases, going on there. That is, the air is actually rarefied. And what I'm trying to say is that the air is actually scanty, or is bombarded with a bit of cosmic radiation. And this cosmic radiation is what makes the air, to be rarefied or to be ionized. And like I said, we have we have the mesosphere, and we also have the thermosphere. And if you get the thermosphere, you discover that the temperatures, increases gradually in the thermosphere due to this cosmic radiation and ionization that happens in the ionosphere. So after the ionosphere, that is from 483 kilometers upwards, we get to the next layer of the Earth, which is like the last layer, and this layer is called the exosphere. Now, the exosphere is found beyond 483 kilometers, down to the outer part of the Earth. And it is also rarefied because the atoms, of oxygen we have there is scattered. We have oxygen, helium, and hydrogen. And as you go out of the atmosphere, you're gradually getting into space. So after the the exosphere, you've succeeded in leaving the Earth completely, and you're fully into space. So these are the layers of the atmosphere. So let's look at the characteristics of the atmosphere we have. Now, the first feature of the atmosphere is that the atmosphere is actually the gaseous component of the Earth. If you look at other components of the Earth, you discover that the atmosphere is just that layer that is made up of of gases like nitrogen, like oxygen, like carbon dioxide, and the rest. And also, the vertical extent of the atmosphere, from the surface of the Earth is about 1,000 kilometers. Right from the 48 kilometers where you have the stratosphere and the troposphere, down to the exosphere where you go beyond 483 kilometers. So the vertical extent is about 1,000 kilometers, and we have layers of gases, surrounding the Earth. That is it. So if you look up there, you discover that the Earth is actually, gaseous, and we have gases in different layers, all covering us. And when in the troposphere, which is the lower portion of the Earth, we have water vapor, and not just water vapor, we also have clouds being formed there, and all the weather conditions, are actually based on the atmosphere. We also have permanent gases there, like nitrogen is permanent there. We have oxygen is permanent there. We have carbon dioxide is permanent there, and we also have some noble or inert gases right there in the atmosphere. And as you go up, into the atmosphere, the density of the atmosphere decreases as you're increasing the altitude. As you're going higher and higher and higher, the density increases. And also, the atmosphere has an average pressure of 101.3 kilobars, at sea level. That is the pressure of the atmosphere, or will I say the atmospheric pressure at that sea level is about 101.3 kilobars. And Also, in the atmosphere, when you know get there, there's specifically the troposphere. We have what pollutants like dust, like smoke, like sulfur oxide, which are CFC compounds, and also we have nitrogen oxide and other forms of pollutants that we can find in the atmosphere. Now, let's look at the relevance. Why is the atmosphere important? What is the usefulness of the atmosphere? Now, the atmosphere actually helps to control heat, you know, and other radiations from the sun. Like I told you, if you get to the stratosphere, where you have the ozone layer, you discover that this ozone layer actually filters out about 90% of harmful radiation, you know, coming from the sun. So if the atmosphere is not there, we are going to, you know, suffer a tremendous heat effect from the sun. And the atmosphere also is a natural reservoir of many gases. You know, gases that we use in the industries today, like nitrogen and oxygen, we actually have a large reserve of it in the atmosphere. And even in the welding industry, to be precise, we also make use of argon. And this argon is a noble gas that can be found in the atmosphere. And also, the atmosphere, you know, like I said, contains ozone. Ozone is O3. That is 3 atoms of oxygen. And this ozone actually helps the Earth to avoid the harmful effect of UV radiations coming from the sun. So we look at more importance or uses or relevance of the atmosphere. The atmosphere, if you look at it, we have that various weather conditions or, you know, phenomena or climate, you know, phenomena are actually, you know, dependent on the atmosphere. When we look at things like winds, we look at clouds, we look at water vapor, we look at rainfall, temperature, and snow. These things are actually made possible by by the atmosphere. So what I'm trying to say that if the atmosphere never existed, we are not going to have we are not going to have this phenomena, you know, in reality. And trust me, our world will be our world will be void and not unless habitable. It's not possible for us to even live here on Earth. Let's just face the reality of it. So that's one relevance of the atmosphere. And also, gases that we need for survival, you know, both for plants and animals, are actually found in the atmosphere. For instance, oxygen and also for carbon dioxide. You see that plants and animals or human beings, they make use of these gases, and they interchange them during respiration, and also during transpiration in plants too. And that's a very important factor when you look at the atmosphere, because without these gases, plants will not thrive, human beings will not thrive on Earth here, and also animals as well will not also thrive on the Earth's surface. So that is just it. So we use this oxygen for for respiration and also for combustion. And the atmosphere is actually a habitat for avians and also for some bacteria or organisms, you know, like bacteria flying in the atmosphere from one person to another or from one place to another. So these are the importance of the atmosphere. So let's look at the next layer of the Earth. The next layer of the external Earth is called the hydrosphere. Now, when you hear the word hydro, we are actually referring to to water. So we are referring to every natural water body we have on the Earth's surface. Every natural water body you have on the Earth's surface is classified as the hydrosphere. So we have examples like river, we have oceans around us like the Pacific, Atlantic, and North Atlantic and South Atlantic Ocean, and the Mediterranean Sea and the rest. These are examples of the hydrosphere. And not just that, even the underground water too, and the ice sheets in the polar region, they are all part of the hydrosphere. And if you look at the Earth, you see that the 97% of the water we have on Earth is actually categorized as the hydrosphere. So meaning that the other 3% can be artificially made, but when you look at the volume of water we have on Earth presently, you see that 97% is actually gotten from the hydrosphere. So that's the hydrosphere. Then we go to the other layer of the Earth, which is called the biosphere. Now, the word bio means life. So we're actually talking about the layer or structure of the Earth that supports life, or that supports the growth of living things. So the biosphere is actually the zone of all living things on Earth. So it covers the lower atmosphere and the upper lithosphere, which is the part that we are actually resting on or we are living on. So from the stratosphere down to the upper lithosphere, we classify it as the biosphere. So it is a part of the earth where we have things like human beings, things like bacteria flying here and there. We also have birds. We also have, plants, growing around that region. So every, organism, is actually found in the what? In the biosphere, ranging from human beings down to what? Plants, animals, and even microorganisms on the lithosphere and on the lower atmosphere. So that is the what? Is the biosphere. Then considering this, we have the internal zones of the earth. As we've looked at the external, which is the atmosphere, the lithosphere, the hydrosphere, and the biosphere. Then we also have the internal, the ones that are inside. And the internal layer of the earth or zone of the earth is actually made up of three, which is the lower lithosphere, or you can call it the earth crust. Then we have the mesosphere or the mantle. Then we have the bathysphere or the core. But before we look at this, the external structure of the earth actually work hand in hand with one another, like they depend on each other. So you cannot rule out one of the external structure of the earth, like the atmosphere. The atmosphere has its own relevance because we have gases there, and we have beds, and we have UV radiation and the rest going on there. So that's how they work hand in hand. And if you come down to the internal zone of the earth, where we have these three components, from the lower crust down to the inner core, we'll look at them one after the other, and they are actually separated by what we call discontinuity, and we're going to look at them during this lesson. So let's just look at it now. Now, if you look at the diagram on the screen, you'll see that we have the internal zones of the earth, and they are separated by what we call discontinuity. So the first two layers are actually called the lithosphere or the earth crust. And the earth crust is actually made up of two layers, which is the oceanic crust and the continental crust. Now, the continental crust, and the oceanic crust down below. Now, the oceanic crust is actually the part where we have where we have the water body and the ground floor. Then after the oceanic crust and the continental crust, which make up the lithosphere, we head straight to the next layer of the earth, which is called the mantle. So the mantle, before the mantle, we have a boundary, a seismic boundary per se. We call it the Mohorovičić discontinuity. So after that, you get to the mantle. So in the mantle, we have the upper mantle and the lower mantle. But in the lower mantle, the boundary between both is called the asthenosphere, which is like a seismic region, or just a space between the lower mantle and the upper mantle. Then when you go beyond the lower mantle, you get into the core of the earth. The core is like the midpoint of the internal structure of the earth, and the core is divided into two zones, which is the outer core and the inner core, and it's rich in minerals like nickel, like iron, and also like sulfur. So we're going to look at these zones of the earth one after the other. So let's start with the first zone of the earth, of the internal earth. So the first one is called the lithosphere, or you can as well call it the earth crust. So if you don't call it lithosphere, you call it the earth crust. So if you look at the lithosphere, the lithosphere is actually a solid layer, and in the lithosphere we have rocks and minerals, rocks like granite, and these rocks are actually rich in minerals like silicon, like magnesium, like aluminium. We have it in abundance in the lithosphere, specifically the oceanic crust and the continental crust. So if you look at it, it has a thickness of about 50 kilometers from the Earth's surface down. So the lithosphere is actually 50 kilometers thick, and is divided into two. And the continental crust, which is rich in silicon and aluminum, is actually of a density of 2.7 gram per cm cube. That's how thick it is. Then the oceanic crust is actually 3.0 gram or 3.0 gram per per cm cube, and we have the continental, crust floating right above right above the oceanic crust, and the oceanic crust, it forms the basement of the ocean floor. So this is a diagram showing the discontinuity of the Earth as you move from one layer of the internal Earth to the next layer. So this is the lithosphere as we have here. It's made up of the oceanic crust and the continental crust. So if you look at this, we'll have the Sima right above, floating on the Ciel. Then when you go beyond the lithosphere, we have what we call the Mohorovičić discontinuity. I told you in 1909 it was discovered by a scientist called Mohorovičić. So then after that, you get into a brief space called the asthenosphere, which is in the mantle region. Now that is the asthenosphere. Then in the asthenosphere, we have the upper mantle and the lower mantle. So we have the Ciel and we have the Sima. So the Ciel is made up of silicon and aluminum, and the Sima is made up of silicon and magnesium. Now the Ciel is right above the Sima, and rocks in this region are actually rich in silicon and magnesium, while the rocks here at this upper region of the internal Earth is rich in they are rich in silicon and aluminum. So between the upper mantle and the lower mantle, that is the mesosphere, we have a boundary or a seismic boundary called the Repeti discontinuity. So when you go beyond the lower mantle, we have, before you get into the outer core, we have the Gutenberg discontinuity, and in between, in the core right there, which is rich in nickel and iron, like I previously said, we have a boundary separating the inner core from the outer core, and the boundary is called the Lehmann discontinuity. And one thing about the core which we are going to look at is that the inner core is actually solid compared to the outer core. So we are going to look at the next zone, which is called the asthenosphere. So like I said, the asthenosphere is just a brief space, and it's simply a mechanically weak region of the upper mantle of the Earth. So it lies below the lithosphere, and is in a range of value of 80 to 200 kilometers below the surface of the Earth. So it goes deep to about 700 kilometers. So when you leave the asthenosphere, that space, you get to the mesosphere, which is the mantle. Now the mantle is right below the lithosphere. So the mantle actually is actually of a distance of about 29,000 kilometers, and it contains a rock that we call peridotite. And peridotite is the major rock you have there, even if we have other types of igneous rock in that zone. And the minerals that you can find there is, we have iron, we have calcium, we have silicon and aluminum. Like I said, we have Sima and Ciel when you're going down the crust. And the temperature there increases as you go down before you get to the core of the Earth. So the mantle has a density of 3.0 gram, down to 3.3, and the seismic boundary between the lithosphere and the mantle is called the Mohorovičić discontinuity in 1909, to be precise. So we look at the next layer after the mantle. We have the core. The core, if you don't want to call it core, you call it the barysphere. Now the barysphere is the central layer of the Earth, and is between 2,897 kilometers to 6,370 kilometers below the Earth's surface when you go down. So the core of the Earth, like I said, is rich in nickel, is rich in iron, is rich in cobalt too, and also a bit of sulfur. And the inner core is actually solid due to the force or the compressing force that that is going on at the core of the Earth. So the outer core is liquid and the inner core is solid because of this compressional force we have there. So as you can see, this is a diagram showing the inner and outer core of the Earth. So we have the inner core here and we have the outer core here. Then at the top here we have the crust, that is lithosphere, between 80 to 40 kilometers. Then for the mantle is 2,900 kilometers below. Then for the outer core and the inner core, they have a thickness of about 2,250 kilometers, and also for the inner core we have a thickness of about 1,300 kilometers. So this is how the inner structure of the Earth looks like, and it's simply divided into what? Into three zones. That is the core, the mantle, and the crust. So let's look at the two cores of the Earth. Like I said, we have the inner and outer core. So the outer core is actually fluid, or let's say it's in its liquid state, while the inner core is in a solid state. I'm going to give reasons for this. Now, the temperature at the core of the Earth is actually estimated to be as high as 5,000 degrees Celsius, and as a result of that, you discover that the core of the Earth is meant to be what? Meant to be in its liquid state, because at this temperature, it's very obvious for some elements, to be in their boiling point or in their molten state. But when you get to the central, that is the inner core, due to the compressional forces we have there, we discover that the core of the Earth is usually kept solid. That is the inner core of the Earth. And the boundary between the inner core and the outer core is called the Gutenberg's discontinuity, and is named after the person who discovered that seismic boundary in 1859. And the density of the core is about 10.7 grams per watt per cm cube. So let's look at questions from the exam guide. So we go straight to the exam guide we have here, and we are going to take questions from 2011. So we're going to take questions from 2011. Okay, 2011. So let's get started with 2011. So I'll pick a question from number 15 and number 16. Now, number 15 says the lowest layer of the atmosphere is the dash. The lowest layer of the atmosphere is the dash. Now, A is stratosphere, B is troposphere, C is thermosphere, D is exosphere. Now, if you look at the options, the correct answer there is definitely going to be what? The troposphere. So let's look at the next question. It says, which of the following is the most abundant in total volume within the atmosphere? We have A, hydrogen, we have B, argon, we have C, nitrogen, we have D, carbon dioxide. Now, if you take your mind previously to the composition of gases in the atmosphere, we talked about nitrogen having a percentage of 78% by volume. So the gas there with the highest volume is definitely going to be what? Going to be nitrogen. So let's take another question from 2015. 2015. Let's go 2015. Let's look at question. Let's go to question number 14. Now, the question says the part of the Earth crust which is made up of silica and alumina is the dash. Now we have CIMA, we have mantle, we have bathysphere, and we have CL. Now, if you look at the options, the correct answer is the what? Is the CL. The CL is a part of the Earth where the rocks or the minerals there are actually composed of silicon and aluminum combined together. That's the reason for the name what? The name CL. So the correct answer there will be what? Will be option D. Thank you for participating in today's class. You can practice more questions using the Exam Guide app. The app scores and gives a detailed explanation of all the questions at the end of your practice test. You can learn a particular topic of interest with different modes like study mode, mock mode, and practice mode. It also has other features that make learning fun. It's a must-have for all serious students. Download from www.examguide.com if you don't have it yet. See you in the next class. Don't forget to subscribe to our channel, hit the notification bell, and share the videos to people that will benefit from it. Bye.